because everyone here is interested in curing breast cancer or diagnosing it or the pathology of it and so forth. But what I've been interested in for a very long time is the origin of the explosion in breast cancer incidence, which we have seen in the last 30 years. Because, let's see if I can make this work. Because it's widely accepted that at least part of all cancers originate in genetic damage at the cellular level. It's a manifestation of genetic disease at the cellular level. Although there are other aspects which have to do with the control of the proliferation of the initial genetic damaged tissue, we know from epidemiology that more than 80% of cancers are the result of damage to genetic material from environmental carcinogens. Professors Doll and Pito wrote a very influential book in the 1980s in which they analyzed the rates of cancer in different populations and also the association of cancer with particular exposures in various occupations, and concluded that most of the origin of cancer is exposure to environmental factors. Now, if there is a sudden increase in cancer in a population with a stable cancer rate over time, then that means there's evidence there for previous exposure to some agent which has caused a genetic mutation in tissue. Now, the lag between exposure and clinical expression, we do know from a number of studies, mainly studies associated with the exposure to people to radiation from the Hiroshima explosion. We know the lag periods. And we know that the lag time between exposure and clinical expression varies between cancer sites, and it is, of course, a function of the natural proliferation rate of the cells. So in other words, cells that have a rapid normal proliferation rate, like blood cells, the onset of cancer after the exposure is fairly rapid. That's years. And for cells which have a very low natural proliferation rate, the lag between exposure to the mutagen and clinical expression is much longer, up to 20 years or more. Now, for breast cancer, based on the increases in the Hiroshima A-bomb studies, the lifespan studies of the Hiroshima and Nagasaki people, the time lag is found to be, depending upon the level of dose, between about 10 and 25 years. So in other words, if you have a low dose, it takes a long time because fewer cells are damaged, and so it takes longer time for them to proliferate exponentially and acquire all the other genetic lesions necessary for them to run out of control and to cease their understanding of the concept of boundary. Now, there was a sudden increase in breast cancer annual incidence at a point in time. This is from the American data, the incidence rates per 100,000 here, from 1975. And you can see that there was a very sharp increase around about 1980 to 85. So this is an increase from a rate of 100 or so up to about 140. So this suggests to us that something happened between 50 to 20 years before that, which involved a mutation in humans, well, in America in this case. And I gave a talk, I've been studying this area for a very long time, and I gave a presentation in Ontario in 1998, in which I suggested that the only thing that occurred, the only introduction of a mutagen into the world population round about the time, 20 years or so before the increase in 1984, was the introduction to the world environment of a whole range of fission products from the atmospheric nuclear testing. It's quite interesting to me that nobody's ever bothered to look at this. I mean, it seems to me, having looked at the literature for many years now, that the question of the origin of the breast cancer epidemic, if I can call it that, is not ever asked. Or at least if it is asked, then various unpersuasive answers are given. So here we see a graph of the sudden increase, the sudden injection into the world atmosphere of the fission products from the atmospheric nuclear testing, and that mainly we have two peaks. We have one in 1959. then there was a gap because of the partial test ban treaty, and then testing was resumed in 1962, and so you can see this this interesting shape of this cumulative precipitation for strontium-90. That's an interesting shape, which I'd like you to just bear in mind as we continue here. I'm going to have to gallop through this a bit, because I've only got 15 minutes here. So how could we see if there was some correlation? Now, this is not speculation, because strontium-90 and uranium and various other radionuclides came down, but particularly the chemicals associated with calcium, that is uranium and strontium-90, increased in human bone, and they were measured in the United Kingdom, and I think also in the United States, but this is a graph of the increases in strontium-90 in human bone over the period 1959 to 63, and you can see that there are two peaks there. The first peak, they weren't actually measuring it before 1959, but you can see that there are effectively two peaks. There's a 59 peak, and then it goes up, then there's one in about 65, 66. And it's highest in infants and young children, but also it's there in adults as well. So you can see if that 15 to 20 years, you can see it goes up, and then it flattens down slightly. So this is strontium-90 in bone. I was born in 1945. So, and just before the Hiroshima bomb, so probably I'm one of the last people on Earth who developed in the womb without my DNA being bound to strontium-90 and uranium and plutonium. Now, in 1994, I suggested in a letter to the British Medical Journal that it was the weapons test fallout which was the origin of the cancer epidemic. Now, the interesting thing is that in the United Kingdom, where we have reasonably good data, the epidemic began in Wales, a country with high rainfall and much higher precipitation from fallout. So if you're looking at these are standardized registration ratios here, taken from the Office of National Statistics, and you can see that in England, the rate for breast cancer was fairly flat between 1974, when the data started for incidence, and 1985 or 86, when it just began to rise. But if you look at the Welsh data, you can see that the breast cancer rates, the standardized registration rates, went up sharply. Around about 1980 to 85, they started to rise, and they continued to rise. So the first question you have to ask is, what happened in Wales that was worse than whatever happened in England, and which could have been a mutagen that caused an increase in breast cancer? Well, the answer is the fallout, because the measurements of fallout were made in Wales, and because of the high rainfall, the fallout in Wales was much greater. Now, a lot of work went into this graph, and you probably, if you're at the back, you can't really see what's going on here. But it is quite an important set of graphs, because what we've done now is we've gone using mortality data, which in England we have going right back to 1935. You can, in fact, figure out what the rates were by cohort age group, and you can take it right back to 1950. So this is a graph, this is a set of graphs of different age groups. This is cancer rates in different age groups of people from 1955 to 1995. And what you can see here is a clear cohort effect. So you can see a diagonal relationship, certainly in the older people there. Now, I haven't had time to present everything that I wanted to present, and I will present it in the paper that I will write for this conference. But what we see here is an exposure. It's an effect of an exposure of women at puberty. So when breasts are developing, over the period 1959 to 63. So 59 to 63 is the peak period of fallout exposure to strontium-90, and this is milk and also uranium. Both of these substances bind to DNA, and this is what makes them so dangerous, because they are targeting the genetic material itself. And I'll just say a few words now just about the concept of cohort effects and environmental effects. Now, if you have a population exposed to an environmental effect, so like let's say I introduce cyanide into this room, then everybody would get sick all at once. But if I introduce it in such a way that it affects only one section of the people and with a time lag, then you will see a diagonal effect here over time rather than all at once. Okay? And so this is an interpretation of what we've just seen. These are effectively models of what we had earlier. So if you're looking at that there, so now I'm going to model those. This is what they look like. And you can see a cohort effect and an environmental effect here. Oh, right, well done. Yeah, great, thanks. Yeah. Okay, you can see, so here's the cohort effect, see, diagonally. And the environmental effect is the increase here in the background rate. Suddenly there was an increase. So if we go back here, we can see that. So there's an increase, but there's also this diagonal effect here. You can see that there it is, and it goes up there, and it goes up there, and it goes off the scale here. So we're looking at effects mainly in women who were aged 12 to 16, if you like, at the time of the peak fallout. And these are the women who are driving, in my opinion, driving the breast cancer epidemic. Now, so that's the fallout origin. Now just going to go forward with that and talk a bit about some other studies that suggest exactly the same thing, that breast cancer is caused by exposure to radioactivity. Now, this is a study that I published recently, about a month ago, although we did it in 2007. And it shows breast cancer mortality. This is from the Office of National Statistics data at a nuclear site in Essex called Bradwell. This is the nuclear site here. Now, normally what people do is when they're doing epidemiology is they look in concentric circles. But in fact, what you have with releases from a nuclear site is it goes into the estuary mud, goes into the coastal estuary mud here. Now, this estuary here has no nuclear power station. This is called Burnham on Cratch. So that's the river Blackwater, and this is the river Cratch. And you can see that the breast cancer is associated with exposure with people who live close to the mud. And the relative risk is highly significant, and so there's a doubling of mortality risk near Bradwell. That was one nuclear power station study we did. Another one was Hinkley Point. I haven't used this. I haven't put this up here because it's going to be published soon, but it's still in press. So we studied Hinkley Point, which is a nuclear power station in Somerset, and we found that there was a doubling of risk there of breast cancer. Okay, we got 5 minutes, is that? Yeah, okay. Sorry? 2 more minutes. Yeah, okay. Well, we get through all of this. So these are the studies here, and also I should just mention that in America, Jay Gould did a huge study of American nuclear sites and found that there was an excess of breast cancer downwind. We also looked at breast cancer in a town downwind of a Trawsfynydd nuclear power station in Wales and found exactly the same thing. Although the relative risk was higher, we found a 5-fold excess. Now, we also looked at contaminated sea coasts and estuaries in the small areas of Wales. I did this for the Irish government in 2001. And we found that close to the sea, where the contamination was, this is over the period of time, we got an increase in breast cancer here that was higher close to the sea than it was inland. And these figures were standardized for social class. These are the results here. You can see close to the sea, relative risk 1.59. These are very, very large populations, so the statistical significance is very large. And there was a significant effect, 1.5, 9.41. As you go away from the sea, you got these figures, and this is a graph of the relative risk. You can see there's almost 60% more cancer close to the contaminated sediment than there is as you go far inland. This is the distance inland in kilometers. So it's a very sharp seacoast effect. And it's caused by the inhalation of sea-to-land transfer material, which is like metal particles, uranium particles, mainly plutonium particles, which are bound to the sediment. We've also looked at the Baltic Sea, but not very closely because we haven't been able to get the data. They won't give it to us. But the Baltic Sea is the most highly radioactively contaminated sea in the world now, and I live in Riga, which is down here. So we've done some studies of that, and what we found here, looking at the wards in Sweden, is that there was after Chernobyl, there was an increase in the wards close to the sea. You can see these are all increases, but in the wards near Norway, there were no increases. Then also, finally, because I'm going to get thrown off the strand now, I need to point out that we did a study of Iraq, looking at women who had breast cancer, well, all cancers, but we looked at breast cancer, and we also looked at uranium in the hair of the women, and we found that there was an excess risk there of almost 9-fold. So I will leave you with that. And if you want a discussion of the issue, there is, if anyone wants to photograph it, there's a paper on this that was published in 2013 explaining how it is that this all works. So thank you very much for listening, and I'll go and leave the next person to carry on.